Basic of corrosion. Definition, causes, forms, preventive and monitoring. Definition of corrosion. Corrosion is the gradual degradation or destruction of materials, typically metals, due to chemical reactions with their environment. This process often involves the reaction of the metal with moisture, oxygen, acids, salts, or other corrosive substances, leading to the formation of oxides, hydroxides, or other compounds. Corrosion can weaken structures, compromise equipment, and lead to costly repairs or replacements, making it a significant concern in various industries, including construction, automotive, and aerospace. Common forms of corrosion include rusting or iron oxidation, pitting, galvanic corrosion, and uniform corrosion. Causes of corrosion. Corrosion is the natural process that leads to the deterioration of materials, typically metals, due to chemical reactions with their environment. There are 7 main causes of corrosion include. Number 1 is called oxidation. When metals react with oxygen in the presence of moisture, they can oxidize, leading to rust, especially in iron and steel. This is a common form of corrosion. Number 2 is called electrochemical reactions. In the presence of moisture and electrolytes, such as salts, metals can undergo electrochemical reactions that facilitate corrosion. This includes galvanic corrosion, where 2 different metals in contact with each other corrode at different rates. Number 3 is called environmental factors. Refer to the various conditions and elements present in the environment that can influence the rate and likelihood of corrosion. The most significant but not limited to are moisture, temperature, salinity, acidity or alkalinity, oxygen availability, wind and turbulence, pollutants and contaminants, soil pH and salinity, coatings and surface preparation, geographic location. Number 4 is called pH levels. The acidity or basicity of the environment can affect corrosion rates. Acidic conditions often lead to increased corrosion. Number 5 is called microbial influences. Certain bacteria can produce acids or other corrosive substances, thereby accelerating the corrosion of metals, a phenomenon known as microbiologically influenced corrosion, or MIC. Number 6 is called mechanical stress. Stressors such as tension, bending, or vibrations can create microcracks in materials that become sites for corrosion initiation. Number 7 is called coating degradation. Protective coatings, like paint or galvanization, can wear down over time due to weathering or mechanical forces, exposing the metal underneath to corrosive agents. To mitigate corrosion, measures such as using corrosion-resistant materials, applying protective coatings, controlling environmental conditions, and employing cathodic protection systems are commonly used. 10 most significant environmental factors. Environmental factors of corrosion refer to the various conditions and elements present in the environment that can influence the rate and likelihood of corrosion. Understanding these factors is crucial in preventing and mitigating corrosion in different applications, especially in industries such as construction, transportation, and manufacturing. Environmental factors that contribute to corrosion are the following. Number 1 is called moisture. Water is an essential element for corrosion to occur, as it facilitates the transfer of ions and the flow of electrons between the metal surface and the environment. High humidity, rain, or immersion in water can accelerate corrosion. Number 2 is called temperature. Extreme temperatures can affect metal properties, making them more prone to corrosion. High temperatures can accelerate chemical reactions, while low temperatures can slow them down, but still allow corrosion to occur. Number 3 is called salinity. High salt concentrations can increase the aggressiveness of an environment towards metals, such as steel and concrete. Seawater, brackish water, and salt spray can be particularly corrosive. Number 4 is called acidity or alkalinity. Exposure to acidic or basic environments can lead to accelerated corrosion. Acidic environments, such as those found in soil or polluted waters, tend to be more corrosive than alkaline environments, such as those found in seawater or concrete. Number 5 is called oxygen availability. Oxygen is a crucial element for many types of corrosion, such as oxidation and oxygen-dependent corrosion. Areas with high oxygen levels, such as near waterfalls or areas with high humidity, can be more corrosive. Number 6 is called wind and turbulence. Strong winds or turbulence can increase exposure to corrosive agents, such as salt spray or pollutants, leading to accelerated corrosion. Number 7 is called pollutants and contaminants. Exposure to pollutants, such as sulfur dioxide, nitrogen oxides, or hydrogen sulfide, can lead to accelerated corrosion. These contaminants can react with metals, creating acidic environments and promoting corrosion. Number 8 is called soil pH and salinity. The pH and salinity of the surrounding soil can significantly affect corrosion rates, especially for steel and concrete structures. Number 9 is called coatings and surface preparation. Poor surface preparation or inadequate coatings can provide a pathway for corrosive agents to interact with the metal surface, accelerating corrosion. Number 10 is called geographic location. The geographic location of a structure or component can affect its exposure to corrosive environments. Areas prone to high humidity, rain, or coastal salt spray are more likely to experience corrosion. Understanding these environmental factors of corrosion is essential to developing effective strategies for preventing and mitigating corrosion. By taking into account these factors, engineers and technicians can design protective systems, select appropriate materials, and implement maintenance schedules that minimize the effects of corrosion. Forms of corrosion. Corrosion is the gradual destruction of materials, usually metals, through chemical reactions with their environment. There are several forms of corrosion, each with different mechanisms and characteristics. 10 common forms of corrosion are the following. Number 1 is called uniform corrosion. This is the most common form, where corrosion occurs evenly over the entire surface of a material. It is typically caused by chemical reactions with the environment, leading to a uniform loss of material. Number 2 is called galvanic corrosion. This occurs when two dissimilar metals are in electrical contact in the presence of an electrolyte, causing one metal to corrode preferentially to the other. The less noble, anodic, metal corrodes faster than the more noble, cathodic, metal. Number 3 is called pitting corrosion. This localized form of corrosion leads to the formation of small, deep pits on the surface of the metal. It often occurs in stainless steels and can be caused by localized chemical or electrochemical conditions. Number 4 is called crevice corrosion. This type occurs in confined spaces, crevices, where stagnant electrolyte can accumulate, leading to a localized breakdown of the protective oxide layer and accelerated corrosion. Number 5 is called intergranular corrosion. This involves the corrosion along the grain boundaries of a metal. It can occur due to segregation of alloying elements at the grain boundaries or due to the precipitation of phases that make these regions more susceptible to corrosion. Number 6 is called stress corrosion cracking or SCC. This occurs when a metal is subjected to tensile stress in a corrosive environment, leading to the formation of cracks. This type of corrosion is particularly dangerous as it can occur without significant overall metal loss. Number 7 is called erosion corrosion. This results from the combination of erosion due to fluid motion and corrosion, leading to accelerated material loss. It often occurs in areas with high fluid velocities, such as pumps or pipelines. Number 8 is called filiform corrosion. This is a form of corrosion that occurs under a film of paint or coating, manifesting as thread-like filaments creeping under the coating. It typically occurs in environments with high humidity and can affect coated metals. Number 9 is called bimetallic corrosion. Similar to galvanic corrosion, this type occurs at the junction of two different metals, particularly when they are in contact in an electrolyte. It can lead to serious degradation of one metal in the presence of the other. Number 10 is called microbiologically influenced corrosion or MIC. This type of corrosion is caused by the presence and activity of microorganisms, such as bacteria and fungi. These organisms can alter the local environment, leading to accelerated corrosion. Understanding these different forms of corrosion is crucial for preventing material degradation in various applications, including infrastructure, transportation, and industrial processes. Rehabilitation measures and protective coatings are common methods to mitigate corrosion effect. Preventive measures of corrosion. To control and prevent corrosion, consider the following strategies. Number 1 is material selection. Choosing appropriate materials that suit the operating environment. For instance, using stainless steel or coated metals in corrosive environments. Number 2 is coatings and linings. Applying paints, varnishes, or other protective coatings to create a barrier between the metal and corrosive agents. Number 3 is cathodic protection. Using sacrificial anodes or impressed current systems to protect metals against galvanic corrosion. Number 4 is environmental control. Reducing exposure to moisture, using desiccants or controlling temperature and humidity. Number 5 is regular maintenance. Conducting inspections and maintenance to identify early signs of corrosion and implement repairs or protective measures promptly. Number 6 is design considerations. Designing components to avoid crevices, ensuring proper drainage, and minimizing contact between different metals. Corrosion monitoring technique. Regular monitoring of corrosion can help identify issues before they escalate via techniques like ultrasonic testing, visual inspections, and corrosion probes. By comprehensively understanding the types of metals, types of corrosion, environmental influences, and preventive measures, engineers and maintenance professionals can effectively manage corrosion risks and prolong the lifespan of metal components in various applications. Thank you.